hard, but the first part that we're going to do today shouldn't be. Shouldn't be that hard. What's so funny? Okay. So if you guys remember way back in probably what, 3rd grade when you started learning about fractions, you learned how to, maybe 4th grade. What was the first thing you did? You multiplied and divided. Why? Because it's easier than adding and subtracting. Why is multiplying and dividing easier than adding and subtracting?
Because you don't have to have a like denominator.
You don't have to have like denominators. Now tomorrow, we will get into adding and subtracting fractions that do not have like denominators. But for today, we're going to do 2 things. We're going to add and subtract fractions with like or almost like denominators, and then we will find least common multiples. So starting with example 1, you'll see that they both already have an x minus 2 in the denominator. So we keep the denominator, right? So we have x minus 2. And we add the numerator. Now, if they were just numbers, we'd add them together. But they're not numbers. They're binomials. So we're going to combine like terms. So x plus 2x is 3x. And a positive 1 and a negative 7 is negative 6. Now, that was easy. There may be an extra step at the end. In this case, I'm talking, right? What do you see here that could happen?
Simplify.
You can simplify. AJ, how?
6 into 2 and then it makes it 3.
What about 3?
It says 3x minus 6 is 3 of x minus 2.
Okay. Now, that won't happen every time, but be aware that that's a possibility. You may have to simplify the numerator by factoring in order to cancel out denominators or cancel out factors in the numerator and denominator. What's that?
So the answer is just 3.
So the answer for this one is just 3. Yes. Okay. Now that won't happen that often, but just be aware that it could happen. Okay. Take a look at the one in the box there. Instead of a binomial in the new denominator like we did in that first one, this is just a monomial, but notice it's the same. Excuse me. So you keep your 5xy. Add your numerators or combine like terms, except they're not like terms. So we just leave 4t plus 7. Now, can I factor 4t plus 7? No. So there's nothing I can do here. We're done. That's your answer.
Is that all we're doing?
Pretty close. Now, look at the next step. The next step is subtracting. Now, when we subtract polynomials, it is like, remember when we had just polynomials? If we were subtracting one, what did we have to do? We distributed the negative sign, the minus sign. So really, it's going to look like that. Right? So plus a negative 4m minus 5. And when we do a negative 4m minus 5, we actually have to change both of the signs. So it's going to be 2m plus 6 minus 4m plus 5 because we distribute it to both of those terms. So combine like terms, what do we get? Plus 11. Can I factor a negative 2m and 11? No. So we're done. Oh, I put an x in the bottom. It should be an m. Doesn't change it. Still doesn't. I still don't have common factors. Questions on that? Okay, same thing in the box. There's another example. Just remember that when it is subtracting, we change all the signs of that polynomial. So it's going to be a negative 4m and a minus 2. So a negative m minus 7 over m plus 4. Nothing I can factor. I could maybe factor out a negative 1, but does that help me in the bottom? Is it going to make it there are no like terms? So done. Okay? Questions so far? All right. Does anybody look down on these 2 examples yet?
Yeah.
Now, are they the exact same denominator? No. They're very close though, right? So Inverse, well, because the denominator is the inverse. In the first one, 2k is positive and 5 is negative. In the second one, the 5 is positive and the 2k is negative. So how can I make them so really simple? How can I make it so that they are the same? What if I take both the numerator and the denominator of that second fraction times the negative 1? It's going to change all the signs, right? Now it changes the sign of the numerator too, but I don't really care about that for now. I need a 2k minus 5 in the denominator. And if I multiply them both by negative 1, I get negative 5 plus 2k, and in the numerator I get negative 1. Now isn't negative 5 plus 2k really 2k minus 5? Okay, so now I have a common denominator, but I'm subtracting, so what do I have to do right here? Change the thingamajiggers? Is that what you said? Very well put, very well put. Okay. So we have really just 3k, because the negative 1 and plus 1 would cancel. Now, can I reduce anything with that fraction? No, we can't. We can't. Right? Because this is a monomial, this is a binomial, we are done. What? All right, this one. So now you'll see, I'm gonna cheat a little bit. I'm just gonna do this. I'm gonna make this negative and then make this n minus 4. Is that fair? Because that's what we just did, right? But be careful, if you need to make it the inverse denominator and your numerator is a binomial, make sure you change both sides, okay? Or really all the signs in the whole thing. So we've got 3n minus 6n, which is negative 3n. Can I reduce or simplify in any way there? We are done. Okay, so that is as far as we will do with adding and subtracting with like denominators.
Are we done?
Hold on. Shh. No.
Since it's plus though, wouldn't it make the middle sign a negative? So then you would have to remake the upper sign back to a positive 6.
No.
Hi.
We are still going to finish the back side of the first page.
Okay.
Because it's easy.
Only like 4 questions here. Oh, these are super easy.
So, how many of you remember hearing the term the least common multiple or greatest common factor?
Yeah.
Not since I was
Okay. Now, shh, I need you to listen. We are really pretty good with greatest common factors. So the biggest number that you can divide them by. But least common multiple, it's kind of tricky because they use the word least, but really we're talking about a bigger number. We're talking about the smallest number that they can both multiply up to. Okay, so when I have monomials like we do in this first example, first you find the least common multiple of 12 and 21. Does anybody know what that would be? It is 84. How did you do that?
Oh, no. Wait, I thought factors.
Not factors, multiples. You just multiplied it out until you found a common, right? All right, which you can absolutely do. You can just keep multiplying until you find the first one where they're the same. I'm going to show you a shortcut. You do not have to use it. All right, but watch what I do. I'm going to break the numbers down into factors. And if I break 12 down into 3 and 4, now typically I would say you have to take 4 and make it 2 and 2. Except I don't have any 2s or 4s over here, so I'm not going to worry about it. Now look at this. What do they have in common?
Trace.
So if they have something in common, we're only going to use that one time. But then we have to use everything else. What's 7? What's 3 times 7? And 21 times 4? Now you do not have to do it that way. You can simply keep multiplying till you find the smallest number they both go into.
That was just a shortcut.
That was a shortcut. Okay? Now in terms of variables, remember, they both have to multiply up to this. So there has to be an R, an S, and a T in my multiple. And there has to be the largest amount of each variable. So the variable, it has to be the largest amount of each variable. Not just the common ones, of all of them. So look at the R's. I have an R cubed and an R squared, so I need an R cubed. I have an S and an S squared, so I need an S squared, and I only have one T, so T.
That's the answer.
That is the least common multiple.
Oh, that was fun.
We probably, if I'm being honest, should have started with this second one. It is easy. You guys, can you do it?
Probably
12.
12x squared.
12?
12x to the third.
There you go.
Come on, Big D.
The largest of them. So, because it's 4x to the third?
Yes.
I'm going below it. Yeah, I was going below it. Sorry. All right. Now, shh, quiet, please. How did I get 12? Quiet, please. Somebody asked me a question that I didn't hear? Okay, that's what I thought. Notice in the other column, I don't have monomials. I have binomials or trinomials or even products of binomials. When we are finding the least common multiple of a trinomial, guess what we have to do first? Factor. So let's factor both of these. I've got this one pretty easy, minus 4 plus 1, right? Anybody have the other one? I know it's got to be a 2x and an x, right? I know one's got to be plus and one's got to be minus. I also know that the number I put here has to be multiplied by 2. And 3 is prime, so it's got to be 3 and 1. Very good. So, take a look. What do they both have in common? So guess how many x plus 1s I need? Just one. But I need to include this one, and I need to include this one. Because it's a multiple. I have to multiply it up to that. And you know what? I'll let you leave the answer like that. Don't multiply it out. That's a mess. I'll let you leave it just like that.
I think we have to use this shortcut that we don't
Oh,
use.
yes.
But he doesn't know where to go, so I chill.
Okay. McT comments. Got it. I will. Thanks. Okay.
Wait.
Factor the second one. I don't like this.
So we have to use this
This guy's
shortcut.
got uglier since.
N plus 4 and N plus 1.
Most.
Very good.
Hey, neighbor.
I'm a neighbor.
Should we tell Mr. Shepherdson he's being recorded?
Yeah, you are.
No, you're fine. All right. So did you get this bottom one? This one's kind of tricky. This one's kind of tricky. Think back to what I told you about your variables. I said we have to use the variable and we have to use the one with the most exponents. I say that because what do we have here? Okay, so I have an n plus 1 once here, but I have an n plus 1 twice over there. So how many n plus 1s do I need? 2. The most. So, and obviously we need the n plus 4. Is that Shep again? No. Mr. Franks. And that's the answer. And I'm done, so I'll hit stop.